In the previous video, we saw how to launch the Async IO event loop and scheduler and add coroutines to it as tasks to execute. In this video, we'll learn about Async IO's future class and how to wait for data we don't have yet. Async IO's future objects look and behave pretty much like concurrent.future's future objects, but they're not interchangeable. They have subtle differences in behavior and, of course, major differences in how they interact with the underlying systems, which are completely different. Still, each future is a way of referencing a value that may or may not have been computed yet, and if necessary, a way of waiting for that value to become available. The most commonly used feature of a future is to wait for its value to be determined and then retrieve the value. For Async IO's future objects, that is done by simply awaiting the future. That will tell the scheduler to pause the coroutine until the value of the future becomes available, after which the future's value is sent into the coroutine as the result of the await expression. If the future represents a raised exception instead of a value, that exception is re-raised from the await expression. If we don't want to wait, we could call the done method to check whether a future is ready. And if it is, we could call the result method to retrieve the value. So, the syntax and semantics are a little different, but the basic idea of a future is the same in Async IO and concurrent.futures. When we're working with Async IO, we use future objects in all the same places we might in concurrent.futures. There's one circumstance where even using futures doesn't make it simple to wait for data, and that's when we want to process a stream of data values as they arrive. Sure, we could loop over an iterator of future objects and wait for each of them to become ready to provide their values, but that's clumsy and suffers problems with knowing when to stop the iteration. Instead, Python provides us with an asynchronous iteration protocol, which allows us to write our fetch the next value function as a coroutine. That means that the iterator can wait for each value to arrive and simply return it. Our loop works properly and we avoid all the confusion about when to stop. Why do we need a special async for statement and a separate asynchronous iteration protocol? It's because asynchronous iteration only makes sense inside of a coroutine. Having a separate looping statement and protocol keeps us from stumbling into ambiguous situations where the computer isn't sure what we want it to do. In this video, we took a look at using a future to wait for a single value or an asynchronous iterator, which may well use futures internally, to wait for a sequence of values. In the next video, we'll be looking at synchronization and communication between asynchronous coroutine tasks.